Today we're going to talk about locality of storage access. What is locality of storage access and why it is important? So, access locality means the ability of software to make good use of the cache. We'll talk about what is the cache exactly next time, but basically it's making a lot of use of the same memory elements repeatedly. Memory is broken into pages. That's how it's organized. And if software uses the same page or the same neighboring pages repeatedly, then it has good access locality. And hardware is designed to speed up this type of software. So if the software has good access locality, then it would run faster on the hardware. So we're going to talk about two types of locality. First, temporal locality, which means locality accessing the same element again and again and again. So the task, suppose it, is to compute the function f theta of x on some long sequence of x's, x1, x2, and so on. Theta is the parameter vector. So for example, if you're using a neural network, theta might be all of the weights in the neural network. So you need these parameters to be available to you for each x that you're going to compute. So it's better if this theta is stored in one page. So if it fits in the cache, the access is going to be fast. If it does not fit in the cache, then each xi will cause at least 2 cache misses and the program will be much slower. So temporal locality means that you're using the same elements again and again and again in quick succession. So you're just keeping them in the cache. On the other hand, we have spatial locality. What is that? That is the type of locality that you don't access the exact same element, but the next element and the next element and the next element. You access elements that are close to each other. That's called spatial locality. So suppose that we want to compute now a different function. We want to basically compute the square of the difference between consecutive pairs of xi. So xi minus xi plus 1, and so on. So let's think about two ways in which we can store these elements. The first method would be to store it in a linked list. And the second will be to store it in an indexed. And we'll see that storing it in an indexed array is much better in terms of locality. So here is the linked list approach. We have our elements. This represents our memory, separated into 4 and a little bit pages. And the elements are basically put throughout, and each element has a pointer to the next element. So 1 points to 2, 2 points to 3, 3 points to 4, and 4 points to 5, and 5 points to 6. So suppose now that we want to do the calculation of the sum of the square of the consecutive elements, we basically have to access all of these pages. Okay, so we need to touch 4 pages, and that's basically going to cost us more time. An array approach would simply be to store all of the elements consecutively, 1, 2, 3, 4, 5, 6. So however we're going to store them, if we store them consecutively, they're going to use at most 2 pages. So in this case, we just need to touch 2 pages, and that will be faster. So you see why storing things in order in an array with an index is more efficient than storing them in a linked list. So to summarize, improved memory locality reduces runtime because memory is organized in pages. And in the next 2 notebooks, we're going to demonstrate the effect of locality, so you can see it for yourself. See you then.